Welcome to This Explainer. Today, we're diving into a truly fascinating intersection of design, ecology, and mathematics. We are going to break down how David Holmgren's permaculture principles utilize natural geometries like fractals, spirals, and lobular edges to completely optimize how energy and resources flow through a landscape. If you've ever wondered how to get way more yield out of way less space, you're definitely in the right place. Let's kick things off by challenging how we usually think about land design. Look around our modern world and you'll see straight lines literally everywhere. Property lines, crop rows, city grids. But if you look at a virgin forest, a meandering river, or even the microscopic structures of a single cell, you won't find a single rigid straight line. Why is that? Why does nature actively avoid the very shapes we rely on so heavily? Well, that question is the absolute key to unlocking true ecological efficiency. To figure that out, our explainer today is going to cover 4 key areas. First, the geometry of permaculture. Second, maximizing the edge effect. Third, Zone 1 and micro-pattern complexity. And finally, Zone 3 and macro-scale efficiency. So let's jump straight into Part 1, the geometry of permaculture. Let's look at the basic shapes that define human design versus natural design. Industrial landscapes typically rely on rigid Cartesian grids. Now, these straight lines actually create a lot of environmental friction. They minimize edge boundaries and often act like physical walls blocking the natural flows of water and nutrients. Permaculture, on the other hand, leans heavily into ecological engineering. By copying nature's complex geometries, think spirals, branchings, and fractals, we're actually optimizing the thermodynamic processes of the landscape. We're basically letting the geometry do the heavy lifting of energy transfer for us. Moving right along to Section 2, maximizing the edge effect. So why exactly are these natural, nonlinear shapes so incredibly productive when we apply them to our own spaces? Well, it all boils down to the edge effect. In ecology, the zone where 2 different systems crash into each other, like where a forest meets a meadow or land meets water, is called an ecotone. It is consistently the most vibrant, diverse, and productive part of any landscape. Nature uses wavy, lobular, and crenellated patterns to absolutely maximize this interface. Just think about the highly folded, zigzagging edges of our own intestines absorbing nutrients, or how a meandering river supports a massive, thriving ecosystem along its banks. And the best part is, we can easily copy this biomimicry in our own designs. By just ditching straight lines in favor of wavy or crenellated edges, you can instantly boost your productive space. Let's say you're building a pond. If you change its edge from a perfectly straight circle to a wavy, lobular shape, you can literally double the effective circumference. Without requiring even an inch of extra land, you've just doubled the space available to plant highly productive edge species. It's a total game changer. All right, let's zoom in a bit for Section 3, Zone 1 and micro-pattern complexity. In permaculture, Zone 1 is that highly trafficked manual maintenance area right outside your back door. Let's see how high-level ecological math plays out here. The herb spiral is an absolute masterclass in using 3D fractal patterns to optimize a tiny space. Usually built right near the kitchen, it takes what would normally be a flat, circular garden bed, maybe 1.6 meters across, and wraps it up into a 3-dimensional ascending spiral mound using stone or brick retaining walls. Now, here's where the math gets really cool. A flat 1.6-meter bed gives you roughly 2 square meters of growing area. But by building a central soil mound to a height of just half a meter and spiraling it upward, your physical planting surface area expands to about 2.4 square meters. That is a staggering 20% gain in actual physical growing space completely contained within the exact same geographic footprint. How amazing is that? But wait, it actually gets better. Beyond just saving space, this 3D geometry actively engineers its own distinct, localized microclimates. The sunny, southern side acts as a thermal mass, soaking up heat for sun-loving plants like rosemary. Meanwhile, the shady northern side stays cool, which is perfect for mint. And because water obviously flows downhill, the top of the spiral drains rapidly, making it the perfect spot for dry soil herbs like thyme, while the base collects all that moisture to create an ideal home for watercress. The geometry literally creates the ecosystem. Okay, let's dramatically zoom out for our final part, Section 4, Zone 3 and macro-scale efficiency. When we shift from a small backyard to Zone 3, which is broad-acre farm territory, the rules of scale change entirely. Out here, highly complex micro-patterns, like those tight herb spirals, are just completely impractical. You can't exactly navigate a massive tractor through a tiny zigzag, right? So broadacre designs have to simplify these edge geometries. We still want to avoid the high friction of a straight Cartesian grid, but we really have to balance the ecological benefits of curved edges with the operational efficiency you need for mechanical farming. To pull this off, broadacre permaculture relies heavily on something called keyline design, which was pioneered by P.A. Yeomans. The whole system is anchored on one vital feature, the key point. If you look at the cross-section of a valley slope, the key point is that exact topographic sweet spot where the upper slope transitions from being steep and convex to being flatter and concave. It's essentially the exact point where subsurface water often breaks right through to the surface. Once you've identified that key point in a primary valley, you can trace its elevation all the way across the landscape. That specific contour line is known as the key line, and this line becomes your foundational baseline for organizing the whole property. It dictates exactly where to place water storage, roads, trees, and it tells you how to cultivate the soil so you can safely capture and redistribute water. Using this key line as a guide, farmers use a subsoiler to cultivate the earth in lines perfectly parallel to it, but here is the absolute genius part of this. Because natural contour lines naturally vary in distance from one another, plowing parallel to the key line actually creates rip lines that end up slightly off contour. This creates a specific pattern that acts almost like a giant physical flowchart carved right into the earth. It gently redirects surface runoff away from wet, flood-prone valleys, pushing it out toward the dry, parched ridges, allowing the water to sink deep into the soil. The data behind designing this way is just mind-blowing. Catching just 1 inch of rain on a 1,000-square-foot surface yields 623 gallons of stored water energy. That's a massive amount of water. By using keyline plowing to slow and sink that water across hundreds of acres, you're literally capturing millions of gallons of water in the ultimate free storage tank, the soil itself. So, the really crucial takeaway here is how permaculture adapts its geometry to fit the scale of the environment. In Zone 1, we fully embrace intricate, manual 3D fractals, like the herb spiral. But as we move out to Zone 3, we transition into these sweeping, mechanically efficient topographic curves. The core principles of maximizing edges and energy flow remain exactly identical, it's only the geometry that scales up. As the laws of thermodynamics remind us, nature demands a return for every gift received. Water, sunlight, and nutrients are constantly entering our systems, and entropy dictates they'll just dissipate if we don't act. We absolutely have to design the geometry of our landscapes to catch and store this energy before it passes right through. Because if we just allow a straight grid to flush all our water away, well, the user ultimately pays the heavy price in lost fertility and really expensive chemical inputs. Whether you're managing a tiny urban balcony or running a 500-acre farm, observing and altering the geometry of your space can unlock some incredible resilient potential. By simply swapping rigid lines for natural curves, spirals, and key lines, you build living systems that basically do the hard work for you. So as you look out your window today, I want to leave you with this thought. Where are the straight lines in your environment? And how will you redesign your own edges?